Hey everybody, it's Mrs. Woolley. Thank you for joining me. A very happy Wednesday to you. Today we are looking at solving equations with the variables on both sides. So in equations, sometimes we have the variables on both sides and we need to combine the variables on the same side of the equation. So you should always try to do that by moving the smaller variable. And that is because it will typically keep the numbers positive for the coefficient and you don't have to worry so much about the sign of the answer. So just like the number -7 and 7 are opposites, we can look at a variable expression, -7x and 7x, as opposites. And you know, when you add a number and its opposite, it makes 0. So we're going to use this idea to help us move a variable to one side of the equation. So if we look at our first example, in step 1, we want to actually add 7x to both sides of the equation. Okay, and so I'm going to add 7x on both sides, and I'm going to line that up right underneath. So it's like I'm forming columns. So when I do that, 7x and a 5x make 12x. And then on the right-hand side of the equation, -7 and 7x are 0. So remember, -7 and a 7 make a 0x, and 0 times x equals 0. So we have 12x equals 36. Our next step is to undo our multiplication. We're going to divide by 12 on both sides of the equation. So we get an answer of x equals 3. Okay. So what I'd like to do is to take a look at a couple more examples. So in example 2, 3x is smaller than 5x, and we do have the variable on both sides, so we're going to move the variable to the right-hand side of the equation. So I'm going to subtract 3x on one side of the equation, and I need to do that same transformation on the other side. So 3x minus 3x is 0x, and 0 times x is just 0. Now I need to remember, it's on the left-hand side, I don't have a 10, I have a -10. And I always tell students, just push that operation to the right and have it travel with the number. So 5x minus 3x is 2x. And now I need to divide both sides by 2. And the quotient of -10 and 2 is -5. So x equals -5. Okay, we're going to take a look at example 3. Example 3 is a little bit different than the other examples because I have both a variable expression and a number on both sides of the equation. So the first thing I'm going to do is move the smaller variable, and since 3 is smaller than 6, I'm going to subtract a 3x from both sides. So 6x minus 3x is a 3x. And again, I want to remind you, push that operation to the right and have it travel with the number. So it'll be -7 equals 14. From here, I have a nice two-step equation. I'm going to add 7 to both sides and then divide both sides by 3. So on the left side, all I have left is 3x. And I know that 14 plus 7 is 21. And now I'll divide both sides by 3. And I get x equals 7. And that would be the solution. Okay, so sometimes when we solve an equation, the variables will cancel out. Now, when this happens, there are two outcomes. Either we have infinitely many solutions, which is called an identity, or we have no solution. And it's called an identity. Or no solution. And sometimes people will call that the null set or the empty set. And it looks like a 0 with a dash through it. Okay, so if we look at example 1, if I subtract 2x from both sides of the equation, the variable drops out on both sides. And then I have this expression, this equation, 8 equals negative 5. Well, that is not true. That's not a true statement. So in this case, there is no real number that would make this equation true, so there is no solution. All right, on problem number, example 2, we need to distribute on the left-hand side. So I'm going to give out that 4, and 4 times x is 4x, minus 4 times 5 is 20, and that equals 4x minus 20. So from here, we can see that the left-hand side and the right-hand side of the equation, they're exactly the same. So at this point, I know any value that I substitute in for x, the left and the right-hand side will be the same. I can go through and subtract 4x from both sides, and then I would be left with a statement, negative 20 equals negative 20. Well, that is true. So that has infinitely many solutions. It's called an identity. All right, I'm going to ask you to try a couple of the extra practice problems. And so this extra practice problem, if you move the smaller variable, it is going to put a 0 on the right-hand side of the equation. So in this case, it might be easier to subtract 7x from both sides. So on the left-hand side, 7x and minus 7x are opposites, so they cancel. And we have 9 equals, well, 4 minus 7x is a negative 3x. Now I'm going to divide both sides by negative 3. And I have an answer that negative 3 equals x. All right, what if I wanted to solve it a different way? What if I wanted to move the smaller variable? Of course I could do that. And I'll model what that looks like. So we have 7x plus 9 equals 4x. So now I'm going to subtract 4x from both sides. And a 7x minus 4x is a 3x. So I have 3x plus 9 equals 0. So in order to solve this, I have to get x all by itself, which means I need to remove the 9 and the 3. So the first thing I'm going to do is subtract 9 from both sides, and I'll have 3x equals negative 9. So at this point, you can see these equations, each side is exactly the opposite when you look at the first problem that we solved this problem first, and it's in the maroon ink. And then if you look here, In the blue, you can see that it's opposites. So we're going to divide both sides by 3, and we still come up with the answer of x equals -3. Okay, so the last problem that we're going to look at, we need to distribute or give out on both sides of the equation, 2 on the left-hand side and a 4 on the right-hand side. Okay, so I'll give out that 2, and 2 times 4x is 8x, plus 2 times 1 is 2. Now on the right-hand side, I'm going to distribute the 4, and 4 times 2x is 8x, plus 4 times 1 is 4. So I notice that the variable expression on each side is exactly the same. So that's how I know I have a special situation, either no solution or it's an identity equation, and there's infinitely many values. It would actually be all real numbers. Anything I subbed in for x, it would be true. So we're going to subtract 8x from both sides. Oh, wait a minute. I think Mrs. Woolley is just didn't make sense. If we look at this, 2 does not equal 4, so we can see there is no real numbers in this case. So when the 8 minus 8x from both sides, I have this statement that 2 equals 4. And that is not a true statement. So there is no solution. All right, thank you for watching this video, and I appreciate all your effort, and you are getting to be great equation solvers. I'm really proud of you. Keep up the good work.